I've designed a concept that addresses a real-world challenge, a smart energy optimization tool that helps people make better energy decisions when solar supply is uncertain. The inspiration behind this solution stems from the reality that many off-grid homes operate in blind spots. Whether in rural regions or even within advanced solar installations, users often don't know how much solar energy they can expect to generate each day. The dashboard is a live interface hosted on Cloud Run. On the sidebar, users enter their system specifications, solar panel size, battery capacity, panel efficiency, and select their location. Live weather data is automatically fetched from the Open Weather Map API. On the right side, the user selects appliances and estimates usage hours. The Optimiser immediately calculates the estimated load, projected solar generation, available battery power, and performs real-time energy balancing. An intelligent advisory engine then generates insightful alerts to guide the user. In addition, I implemented Prophet AI to forecast solar energy availability for the next 24 hours. Cloud Performance Insights also help the user understand how weather variability affects solar generation with percentage-based comparisons between today and tomorrow. The charts provide powerful visual analytics, showing projected solar input, live telemetry, and breakdown of appliance demand versus energy budget. On the back end, the architecture is fully cloud native. Live telemetry and AI inference logs are streamed into MongoDB Atlas, leveraging time series collections for high-performance queries and historical analysis. The app is containerized using Docker, deployed serverlessly via Google Cloud Run, and the CI/CD pipeline built in GitLab automates all Docker builds and deployments to Artifact Registry. What makes this solution unique is its adaptive intelligence, blending weather-driven AI forecasts with real-time telemetry and human configurable models. It's designed to be lightweight, scalable, and applicable to rural electrification, smart grid pilots, and low-income energy access programs. This development reflects my passion for applying AI and automation to solve critical real-world problems. I'm excited to build on it further with support from Google Cloud, MongoDB, and GitLab. The ultimate goal is to contribute to net zero and energy sustainability through intelligent, cloud-driven solutions.